Hello student, welcome to my official YouTube channel Mathematics All Levels, and we are discussing the previous year important questions of Edexcel and Cambridge boards. So let's directly come to the questions. Yeah, the first question is of initial rate versus initial value. Coffee is poured into a cup. So they have given a certain equation for us to analyze it. So for us, they have given that H is equals to AE raised to the power negative B cross T plus of 30, where H is the temperature of the coffee, T is the time, and T is the time, and A and B are constant according to the question. Initially, the temperature of the coffee was 85 degrees Celsius. So for this case, student, the temperature was 85 degree initially, means initial value. It means the time interval will be 0, because no time will be passed, or no time will be means no time will be passed if the initial temperature was 85 degrees Celsius, because from this only the temperature was started to decrease or increase. So initially we can take T equals to 0. So H is equals to, now plugging this value here, we'll get A E raised to the power negative of B cross of T, that is 0, plus of 30. Now H in the question, it is given 85 degrees Celsius, because initially they have mentioned. So 85 equals to A E raised to the power negative B cross 0, this will be 0, plus of 30. Okay, so on transposing 30 to the left hand side, we'll get 85 negative of 30 equals to A. That is the value of A. So the value of A will be 55. Okay students, this value we have got for A. Now in the second statement, student, they have given that the coffee was cooling at a rate of 7.5 degrees Celsius per minute. Okay, one more important term is that it is cooling. It was cooling. This coffee was cooling. So whenever this term comes in the question rate, it means we need to differentiate it. Okay, so if we differentiate the given equation dH by dt, so we need to differentiate this particular equation, student. So what we'll get, A cross of negative of B e raised to the power negative B cross T plus 30, the differentiation of this term will be 0. So we'll keep it as 0. Now in the question they have told that it was cooling at the rate of 7.5 degrees Celsius per minute. So cooling, so means the temperature was decreasing. So we'll take negative of 7.5 as the rate of cooling. A we have calculated, student, that was 55 cross of negative B cross of e raised to the power negative B. Since the case was initial, so we'll take T as 0 here. So what we can get from here, 7.5 divided by 55, that is equals to B, and this value well, again it will be equals to 0. So the value of B will be 7.5 cross of divided by 55. So this will be equals to 0.136. A student, so this is our value, 0.136, roughly 0.13636. Okay, now what they have asked us, that what will be the complete equation linking the H and T, giving the value of B to 3 decimal places. So we have already got the values here, and so the complete equation will be H equals to A is 55 e raised to the power negative of 0.136 cross T plus of 30. Okay, so this is our complete equation, students. Now let's move to the next question. This question I've taken from the concept of linearization and constant recovery. So you can see they have given a certain graph here of a heart rate of a mammal measured in beats per minute, and they have given us a equation for this heartbeat. Okay, let's do it. Okay, in the question they have also mentioned that the linear relationship between log h and log m. Okay, so this is a line which is represented by y equals to mx plus of c. This is the general form of a line which everyone knows, where y is equals to mx plus of c. M is gradient or slope, you can say. Okay, c is the y-intercept. Okay, y and x we all know. So h is equals to p m raised to the power q. Okay, this we have got in our equation. So if we take log on both the side, what we'll get? We take log on both the side, we'll get log of h base 10 log of pm raised to the power q. I've taken log on both the sides. Now on the right hand side, what we'll do, we'll apply the reverse of product law. So we can say that the value here will be log of p basis 10 plus of log of m raised to the power q basis 10. This could also be written as log of base 10 h base 10 equals to, now this could be written q log of m base 10 plus of log of p base 10. Okay, students. Now why I have made this equation, what is the necessity of this equation, that I want to take this in y equals to mx plus of c format. Now we can directly compare here that log h will be equals to y, m will be equals to q, c is the y-intercept here. So c they have given as, they have given here, it meets the vertical axis at 2.25. Okay, this line they have given. So this part will be equals to 2.25. Okay, gradient they have also mentioned, that is negative of 0.235. So we can say that q is equals to negative of 0.235 and c is equals to 2.25. So on comparing these two equations here, we can see that c will be equals to log of p base 10. From here, we can say 2.25 is equals to log of p base 10. On making it this in exponential form, what we'll get? The value of p equals to 10 to the power 2.25. So here we are getting 177.8. Okay, so this value we have got for p. Now in the next part, student, they have told, okay, in the question first part they have told the value of p and the value of q to three significant figures. So this is the three significant figures. Value of q also we have got, that is negative of 0.235. So a part is done. Now let's move to the b part. The particular mammal has a mass of 5 kg. Now the mammal mass they have given at it as a 5 kg. So, and a resting heart rate of 119 beats per minute. Comment on the suitability of the model for this mammal. Okay, the resting heart rate is also given, that is 119 beats per minute. Okay, so m we have got that is equals to 5 kg. So from here we can say that if I say the heart rate we need to calculate, which is given by the equation h equals to p m raised to the power q. So Pm raised to the power q. So here heart rate will be P. P we have calculated, that is 177.8. M they have given, that is 5. Q we have calculated, that is negative of 0.235. Okay, so this value, the value of H here will be, if I calculate, will be equals to 177.8 cross of 5 raised to the power negative of 0.235 equals to 121.807. So the value of heart rate, student, is coming nearly 121.807. Since the heart rate could not be in point, so we can take it as roughly 122 beats per minute. Okay, so we can see that the heart rate, they have given the resting heart rate as 119 and we have got the value as 122. So we can say that this model is suitable for the mammoth. Okay, so C part, interpret the value of the constant P. So if we are interpreting the value of constant P, so everything, yeah, with reference to the model, what will be the value of constant P? H is equals to Pm raised to the power Q. So Q, okay, heartbeat. So see, this is the value of constant P they have asked. So we can say that means the heartbeat rate and the mass, if I say, is equals to 1. So we can say that this model is resting, means this particular model is having the resting heartbeat rate. The value of P will be equals to 1. Okay, I'll be writing it. Resting heartbeat rate, M will be equals to 1. Heartbeat rate is 1. So the value of P will be also equals to 1. This is the constant, means constant form which we have taken. So we have got the value of P, we have got the value of P here, we have got the value of H here. So this was our question on linearization and constant recovery, students. Now let's move to the next question. That is about the model appropriateness and asymptote interpretations. They have given us question. The area of a nature reserve covered by tree E kilometer square is modeled by the equation. Okay. T is the number of years after 1st January 2005. Find the area of the nature reserve that was covered by tree just before tree planting started. So just before tree planting started, so for the A part, student, the T will be equals to 0. Why is this so? Because the tree planting is just, it has been started. So the number of year passed will be taken as 0. So we can say that A equals to 80 negative of 45 e raised to the power c cross of 0, that will be equals to 1. From here we can say that we are getting A, the value of A equals to 35. Okay. Now if I say in the second line, they have told that area is equals to 60 kilometer of the nature reserve was covered by the trees. Use this information. Now we need to use this information, that is area equals to 60 kilometers square. Okay, to find the complete equation for the model. Okay, so we'll plug in the value on 1st January 2019 and the time was started from 1st Jan 2005. So the number of year passed will be 14. So we can say that t will be equals to 14. Okay, the time duration between these 2 years is 14. So here we can say that a is equals to 80 negative of 45 e raised to the power ct, c cross of t is equals to 14, and a we have given as 60, that is equals to 80 negative of 45 e raised to the power 14 cross of c. Okay, on further solving we'll get negative of 20 upon negative of 45 equals to e raised to the power 14 cross of c. Now if I calculate this, yeah, so we are getting c is equals to, okay, we'll take the log on both the side, or we can directly expand it, means we'll convert into the exponential form. So we'll get 4 by 9. So on calculating it further, we are getting 14c equals to negative of 0.8109. Means I've taken the log on both the sides. So what the value of c we are getting is equals to negative of 0.0579. Okay. Now coming on the third part, that they have told that on 1st January 2020, the owners of the nature reserve announced a long-term plan to have 100 kilometers of the nature's reserve covered by trees. State a reason why the model is not appropriate for this plan. Okay, they have announced that long-term plan of 100 kilometers per hour per kilometer square of the natural reserves. So if I see the model, that is a equals to 80 negative of 45 e raised to the power ct. This was our model equation. Long-term plan is given, so we can take t as infinity. Okay, we can take t as infinity. So we can see here, okay, if we are taking t as infinity, because the time duration is not mentioned here, so we'll be taking t equals to infinity. So what we'll get, a equals to 80 negative of 45 e raised to the power c cross of infinity. Now we can see that a is equals to 80 negative of 45. This particular value here, this particular value, student, this will be equals to 0. Okay, so what we left out with 0. So the value which we are getting, the highest value possible for this reserve to expand will be equals to 80. But they have announced for 100 kilometers square. So this is the reason that this is not the appropriate plan. Okay, this will not be considered as an appropriate plan, because according to the model, the maximum area which could be covered will be 80 kilometer per square, according to the base model which they have given. Okay, so this was our question based on the model appropriateness and asymptote interpretations. So be connected and stay tuned. We will be coming more with the previous year questions, important questions of different topics. Okay, students, thank you.